I know I owe you guys some stuff. I have labeled everything. I haven't uploaded it as yet, but I will upload it today or tomorrow latest. I still have my tutoring on Saturday. If you guys want to take part, just make an appointment if you want to go with me. Once again, though, not for test corrections. For test corrections, go to another tutor, get the help, get their signature, bring it back to me. I give you back half the points that you missed. All right. Um, any questions? Does anybody want to go over anything before I start the lesson for today? Yeah. Okay. Oh, with literal equation? Okay. So, okay. So let's say, let's talk about interest again, right? So interest is equal to the principal times the rate times time, right? Let's say that I had some kind of investment already. There's already been an interest on it. There's a principal that I put in and it's been there for X amount of time, right? But I don't know what rate I'm receiving, right? I don't know if this is actually a good investment or not. I want to solve for R. So over here, solve for R. Hmm? So I want the answer to be like R equals something something. No? Something something.
Wait, you literally want me to solve for R right now?
Mm-hmm.
What? That's the equation?
Mm-hmm.
Oh,
I equals PRT. Yep.
okay. But there's two letters next to the R, so what am I gonna cancel?
Both of them. Because
So
I need R by itself.
T take away T
And how do you take away them?
by canceling them out.
And how do you cancel them out? What operation?
So we're gonna put P over P and T over T. Okay, so P over P and T over T and cancel both of them out.
What you do to one side, you have to do to the other side.
So now I'm gonna do I over P and T. So I over P and T. So I over P and T equals R. But now.
And that's it. That's all I wanted.
You sure?
That's all I wanted. Right?
Thank you.
For me, I would have just done it in one step. Divide by P, right? Divide by T. These will cancel out. When I do to one side, I do to the other. All right. So R is equal to I over PT. Right? So,
There's no equal numbers and it's like, what the fuck?
you think so?
Yeah.
All right, here's another one. 2x minus 3y equals 15. Right? So for this one, say I'm doing an equation of a line or something. I want you to solve for y. Solve for y. Yeah.
So even though it's two X take away three Y, I'm still gonna do two X take away two X and 15 take away two X, or am I gonna do
That
15
way.
divided by two?
No, no,
and
the other
divided by
way.
two?
No,
So
the
take
other way.
away.
Yeah.
Two X. But this is gonna become a negative three Y equals 15 with a two X next to it, because you don't want me to put
Right.
15 over two X.
Right. And then get the y by itself.
So now we do three Y divided by three Y and 15
Not
divided by.
not 3y. Negative 3y divided by, yeah.
This was how, and 15 divided by negative three Y equals, negative five Y, right?
Hmm?
Negative five Y and two X.
Mhm.
So,
Bless you.
thank you.
Bless you.
Thank you. So now I've got a negative 5y next to the 2x.
Okay,
What am I supposed to do now?
almost there.
So do I have to do the 2x take away 2x and the 5y take away 2x?
No. All right,
To combine them, so the answer is y equals negative 5/2.
X and then minus 5, right?
Show
Okay.
me.
So first thing I would do, right? I want the y, so I'm trying to isolate it from everything else. So I subtract the 2x from over here.
Okay.
Well, what I do to one side of the equation, I have to do the other side of the equation. Yeah.
No, I did it right. I did it right.
Yeah.
Yes.
So now I got negative 3y. Hey, I don't know. Did you get the food?
Yeah, I'm done.
Right?
So
When I
now,
was leaving, they just brought it in. Negative 2x plus 15. So now you want to get rid of whatever numbers in front of the y, right? So I'm going to divide by negative 3. But what I do to one side, I do to the other, right? Simplify this down. So this becomes y is equal to a negative divided by negative is a, no, positive, right? Negative divided by negative is positive. So this is 2 over 3x. A positive divided by negative is a negative. And then 15 divided by 3 is 5. So this is my answer.
all right. If you know what, I wrote it down. I'll study this. It's all good.
Okay.
Thank you.
You're
Thank you
welcome.
for at least like trying to help.
You're welcome.
I appreciate it.
All right. Any other questions? Are we good? Nice.
I'm like trying to tell Don that I don't wanna go today, that I missed everything because I don't wanna be with her.
She gonna tell you to go 2 weeks from now, though.
Still,
Yeah.
but either way, she needs to help me reschedule it, cause I don't wanna go on Thursdays at all, and the
Yeah,
afternoon is empty.
no, just tell her you want to go on Wednesdays. That's fine.
Yeah, like
Yeah.
I'm not trying to go on
Yeah.
Thursday.
You could even if you showed up on Wednesday, she'd probably hook you up and be like, yeah, that's cool. No? Yeah. I mean, truth be told, last time I went there illegally, it was it was on a Wednesday and Dawn hooked me up. Mhm.
You only spoke to her over email and I thought she was very sweet.
She is. She's the best. Hi.
Is she
Yeah.
young or is she?
She's young. Yeah. Yeah. I don't know how young though. I mean, you a lady, so you can ask her. But I never asked her.
No, I won't understand.
I mean, you never know. She might be like your new buddy. Yeah, you're in a supermarket and you just see her like, hey, you shop here
What's
too?
up?
Yeah. What was I looking for? Oh, here it is. Yeah. Bam. All right. So if there's no more questions, let's get into what we're getting into today. So we're going to be talking about some probability rules, compound events. Yay, right? So this is that new homework that just got posted, right? So conditional probability and multiplication rules, right? You roll 2 dice. What is the probability that you will get a 5 on each die? Consider a collection of 6 balls identical in every way except in color, right? There are 3 green balls, 2 blue balls, and 1 red ball. You draw 2 balls at random from the collection without replacing the first ball before drawing the second. What is the probability that both balls will be green, right? It seems that these two problems are nearly alike. They are alike in the sense that in each case, you are to find the probability of two events occurring together. In the first problem, you're to find the probability of 5 on the first die and 5 on the second die. In the second problem, you want to find the probability of a green ball on the first draw and a green ball on the second draw, right? The two problems differ in one important aspect, however. In a dice problem, the outcome of a five on the first die does not have an effect on the probability of getting a five on the second die because of this, the events are independent, right? So what happens to one doesn't affect what's going to happen to the other, right? They're two different die. Um, like dice, you know?
Oh.
Yeah, yeah. So an easy way to distinguish is like imagine that they had two different colors, like a green dye and a red dye, for example. Then you could like clearly see that what happens on one doesn't affect what happens on the other, you know? So let's elaborate a little bit on independence real quick. That sounds like an independence. All right, so two events are independent if the occurrence or non-occurrence of one event does not change the probability that the other event will occur. In the problem concerning a collection of colored balls, the probability that the first ball is green is 3 out of 6. Since there are 6 balls in the collection and 3 of them are green, if you get a green ball on the first draw, the probability of getting a green ball on the second draw is changed to 2/5. Because one green ball has already been drawn and only 5 balls remain, therefore, the two events in the ball drawing problem are not independent. They are, in fact, dependent since the outcome of the first draw changes the probability of getting a green ball on the second draw, right? So imagine you have like, sometimes they say an urn, but just looking around the room, let's say you have a bag, right? And in the bag, there's some balls in there, right? They all have different colors, right? So I want to pick out a green ball first, and then what was it? Yeah, green ball first, and then a green ball second, right? Now, when I take out the first green ball, now that means that that's the number of green balls divided by how many balls in total are in the bag, right? But when I go to take out the second green ball, right, there's now one less like green balls that are in the bag, and there's one less overall balls in the bag. So this is what is a dependent event, right? We're gonna go over some other examples, but basically, because I took out one item from the bag, right? Then the total number of items in the bag is now less. So that changes the probability of the second event occurring, right? So that's all I'm trying to say. Mhm.
A certain amount of things,
Mhm.
and you remove something, that is now a dependent thing.
It can be, yes. If I remove it and don't put it back, right? Mm.
If you don't remove them, then it's independent.
Mhm. Hey, listen, I don't know if you're interested, but they got food in Roscoe Brown. Mm. So let me tell y'all what happened, because literally, I think it was last night, I got this, huh? That's a third floor event. The second floor event got the food, but it was late in coming. It's supposed to be there at like 12, and it come to like 1:40, 1:50. That's why. So yeah, yeah, yeah. So so let me tell y'all what happened. I'm checking my email yesterday, right? Like last night kind of thing, right? And then like now I'm like reading it and everything. They sent out an email yesterday saying that there was gonna be a luncheon today. Otherwise I'd have been told y'all about today because I had no idea yesterday what was gonna go on with like during class, right? So the president had a luncheon today. So he was there with people and like with the students, and he was asking them like, "Yo, what you like about the school? What you don't like about the school? What would you change? What would you make better?" Da, 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 all kinds of things, right? People were complaining about the gym times, right? Like somebody actually said that. Yeah, people were complaining about advisement, all kinds of things. And then he was also asking like, give me some suggestions to make it better, and things like that. Yeah, so it was a pretty good event. Yeah, it was a pretty good event. I wasn't there for the whole event, by the way. I had another event before because for some reason every single event happens on Thursday. So like all of us is attending three, four, five events at the same time, kind of nonsense. But anyway, I was at another event. I came late to this one. By the time I got there, food still wasn't served. Like I left at 1:40 to get here, and that's when it just came. No, no, you was in another event that was going on there. Yeah, there was an event on the third floor. You right. You're right about that. There wasn't. There's supposed to be light snacks, but on the second floor they had an event. But like I said, I didn't see that until literally last night. So I didn't even have a chance to tell y'all in class about it. You know. But yeah, that's what happened. It was a good little speech and all that. But I'm just saying, if y'all want food, go grab it, come back.
I'll go.
Yeah.
I'm tired to go right now.
Honestly, I doubt it. I doubt it.
It's
'Cause-
really
no, but you know what the issue is though? The food came so late. I don't think that they're gonna be like, oh, you can only take one sandwich. Like if people want to go there and grab a plate, I feel like they're gonna grab a plate, just to get rid of it. Because that's what I'm saying. No, that's what I'm saying. Because it came so late and there's not that many students. Like they don't want to throw it all out. So it's like take as much as you want now. You know? Yeah. Yeah. But yeah, so that's what was going down today. I don't know if there's any other events going. Yo, tomorrow is a Monday schedule, right? Yeah, they cancel for you. All right, got you.
That's what the teachers.
Yeah, but yeah,
That's very.
yeah, but yeah. So just to let y'all know, if you guys have classes on Mondays, right? Like tomorrow, you have class. Like I have class on Monday, so tomorrow I'm going to class. You know, yeah. Just letting y'all know. All right. I know she was at the event. Yeah. All right.
Is there still food on the event, like the Roscoe Brown event on the second floor?
Oh, you didn't go to that event? You went to another event? Okay, okay. Man, y'all just missing out. Oh man. Either that or y'all rich already and y'all just want to buy your own stuff.
It's both of us big. But I need
It's all
dogs,
good.
I'm way home.
It's all good. It's all good.
Cause I don't either, and I'm going home on a bike.
Uh, next time. Next time. Yeah, there's more events next week, Tuesday, next week, Thursday, you know? Yeah. Oh yeah, all the time. All the time. All the time. You went to the event today? I ain't going to these events.
So we're on the second floor, right?
And this was a legit event. Like there was no, how most of the events have an agenda, watch this movie, let's have this conversation. This had nothing. This was just like come here and just talk with people and like network and eat, you know?
Well, like when I
Yeah.
was, there was playing,
Yeah.
reggae.
Yeah, yeah,
People asked
yeah.
it.
Yeah. Huh? Not on me, no. Sorry. The computer lab, the computer lab has it. Yeah. Yeah. A pen. I got the pencil that I gave you yesterday if you want. Here you go. You're welcome. That computer lab next to us, like down the hall, they got like clean paper in there. So you can always like go there and grab some. Last time when we had a test and I gave y'all scrap, I just took it from there, to be honest with you. And then I brought it right back. The last test that we had, I was talking about like that's when I had the when the scrap paper, that's where I got it from. That's what I'm saying. Yeah. Yeah. Remember when we took the first test? There was scrap paper? Nah.
Mhm.
All right. All right. Let's get back to this real quick, right?
I'm so
Mm-hmm.
sorry.
Go ahead.
What question do you get back into this?
Mm-hmm.
Are you gonna give us like a practice packet for the final?
Yes. I'll talk about that. Yeah. All right.
Yeah, because I want
It'll
to
be
take.
both. Hmm. Hmm. It'll it'll be both. Hmm. All right, so in the problem concerning a collection of colored balls, the probability that the first ball is green is 3 out of 6. Since there are 6 balls in the collection and 3 of them are green, if you get a green ball on the first draw, the probability of getting a green ball on the second draw is changed to 2/5 because one green ball has already been drawn and only 5 balls remain. Therefore, the two events in the ball throwing problem are not independent. They are, in fact, dependent since the outcome of the first draw changes the probability of getting a green ball on the second draw. Why does the independence or dependence of two events matter? The type of events determines, the way we compute the probability of the two events happening together. So if two events A and B are independent, then we use formula 4, which you're going to see, to compute the probability of events A and B. All right. So here we go. Here's formula 4. Yes, this is on your formula sheet in case you're wondering, right? So the multiplication rule for independent events, the probability of A and B is equal to the probability of A times the probability of B, right? If the events are dependent, then we must take into account the changes in the probability of one event caused by the occurrence of the other. The notation, the probability of A given B, denotes the probability that event A will occur given that event B has occurred, right? This is called a conditional probability. We read the probability of A given B as the probability of A given B, right? If A and B, okay, are dependent events, then the probability of A does not equal the probability of A given B because the occurrence of event B has changed. The probability that event A will occur, a standard notation for the probability of A given B is probability of A given B. So when on your formula sheet, when you see A/B, it means probability of A given B, right?
Notation rule for independent events is not the same as the standard notation.
No, there's another formula coming for that.
Okay, so
Right?
should I still write this
Yeah,
standard notation formula?
yeah, right there. Um, Back to what you were saying before though, right? In terms of web work, I forgot to mention this. There's actually a way that you can actually print out all of your questions, right? Like, and get it on like one sheet of paper, and then you could just like write in the answers and then just submit them later, right? I don't know if you would you be interested in doing that? Okay. No, so she was saying how she wanted like paper to work with, right? So I was explaining that there's a way on WebWorks to print out in a PDF format all your questions, and then you can like work on them and then just later on just go type them in and click submit. Or type them in on your phone when nobody's looking. Yeah. Yo, you have to use that, Joino. And then also, what is it now? I haven't printed in a long, it's been years, right? But back in my day, I want to say it was a couple of pennies. It's still expensive, but it's a couple of pennies. Let's say like 5 cents maybe was like a black and white page, right? Yeah. And then if you do duplex, back and front, that's 10 cents, right? But then now say you want to do a color page. I feel the color page was like 8 or 9 cents, and then duplex would be, double that, right? Yeah. Mhm.
Speaking, was it like bag of chips and sons?
It
Wasn't
was.
Snickers and stuff
Mhm.
like that? That was like five.
$1 used to get you a meal like chips, juice, water, all of that, Yeah. 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 Oh man. Kegels, which one's that? I don't remember that. Oh yeah. Oh, Kinko's. Yeah. Back in the day. Yeah. Mhm. Yeah, yeah, yeah. Oh, and just photocopy it. That's fire. Yeah, nice. That's so smart. Yo. Yeah, right, right. That's fire. Yeah. Something that I did. It wasn't at Kinko's though. It was at Staples. More specifically, the Staples in Bay Plaza that closed down. Right. So when I was in high school, they have this college application. It's called the Common App. Right. It's one application that you fill out, and then like there's a buttload of colleges that accept it. Right. So it's less work on you. Just fill out this one thing. Here you go. Here you go. Here you go. Here you go, and that's it. Right. So now it's a colored document, right? So and then you write your stuff up in blue ink or whatever, right? But the thing is that when you send it to the college, you're just gonna make a photocopy of it and give it in, right? So what my guidance counselors told us to do, right, was to make color copies, right? Because when we make a color copy now and the admissions people open it up, they think that we just gave them the original. Like we ain't even consider another college. Like you the only it, like you it, kind of thing, right? So we went there, we went to Staples and we just like, yo, let me get like 19 copies of this, boom. Yeah, yeah, yeah,
Things were so much more simple for them.
yeah. Mhm. I mean, don't get me wrong though, like, how can I say this now? It was hard for them, but simpler. Like, yeah, because like when they used to do a research paper, right? Like they kind of just use whatever they could get their hands on to make the research paper. Yeah, yeah. They had the encyclopedia and all that. But nowadays now we have these databases that we could search, like Google Scholar, for example. I don't know if you guys ever used that before, right? So with Google Scholar, you could search for something like a scholarly written article, right? But when you search for it, it's gonna give you like 190,000. Yeah, you blessed if you get 190,000. A million is, like that's the usual, right? It's gonna hit you backwards. So now you got to narrow it down. But something I like about it that we could use to narrow it down, we can narrow it down by year, right? So I want articles that just came out last year. So yeah, so now our papers today, when we got to do them in class, they're more current. We're not quoting papers from 1892 no more. Like we could quote some papers that were just written, and like it makes more sense today.
There's
You
more
know?
science behind things too.
Yeah. Yeah.
Today it's more plagiarism than it was. Oh, yeah.
Mhm.
Oh, I agree with that.
Yeah. Me personally, like I love AI when it comes to writing. You know, I'm not I'm not at the point where I'll be like, yo, write this for me. Like I never say that to AI, but I will say something along the lines of like I will write it myself and then I would say like fix it. Cause just I don't know why, but I just don't have that mind to make it very plain and clear and concise and da da da, But AI does it, and it does it so well. Like it conveys what I want to say, like I love it, Yeah. But I don't know though, because like it's hard for me to describe it, because I have a thought in my head and I'm doing the best that I can to describe it on paper, but still there's always some kind of grammatical error. There's always like oh you didn't use this word right, or like you could have said all of this whole sentence in one word, kind of situation. Yeah. Right, and what's another thing too? Sometimes I have how can I say this now? I have a big word. I know the meaning of it, and I can say it to you, right? We could have that conversation. But while in the middle of me writing, for some reason I can't spell it. For whatever reason. I can't spell it. I'm trying. Spell check is like giving me some other words. I'm like, it's not that word. Like I'm trying to say the da 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 da, right? So I would really like use a whole synonym, like so now my sentence went from one word to like trying to explain something just because I can't spell the word. But AI will help me with that. Like, oh, you meant automatopoeia. Like,
It's not that I'm a bad writer. I just, to me, simple is better. I like, you see how fancy it is. I don't write
so
for
I've
that.
I've had I've had two people like in my life, I've had two people have like opposing views on writing like that, right? So like one person that I remember, they would say like, yeah, write simple. Because if you could explain it to a seventh grader, then you do understand, you know? That was good. And then I have another person that thought, nah, instead you should write complicated, right? So like use thesauruses, use dictionaries, big words, Yeah. I don't know.
The thing is that it's a waste of time. To me, it's a waste of time to say a million things in such a fancy way when I could say the same shit
Mhm.
in one sentence that you're saying in a whole paragraph.
No, but that's the thing. The fancy way is saying it in one sentence. The simple way is saying it in the paragraph. Yeah.
Two paragraphs in one sentence.
Yeah. Yeah.
Let's say, I feel like I write way less than all these fancy fucking articles I've been reading in class. And then it also depends on.
Because you're writing on a college level. That's why.
Like that is way too fucking fancy. I like everything to be dumbed down and simple. Even this is too fancy.
Well, it's good in a sense because when you wanna sit at big tables, you make big money.
That's true.
You'll be able to, pronounce certain words and certain things people are saying.
Mhm.
Because there are a lot of people that can't pronounce words, but they know definitions, or they do definition.
Right. Right. That's true too.
That's
Mhm. Oh, yeah.
Get over my fancy
Yeah,
phobia.
people like to talk in circles, so only those who are on point will understand.
That's
That's
true.
a really good point.
Lost.
That's a really good point.
I can tell you, back when I was a student, right? I had some coworkers of mine, in tutoring, right? Where they would do that. They would talk in a circle. Like you would come to them with a question, and then they wouldn't know what to do, and they would do some type of circular reasoning with it, but they would eventually come to the right answer. It was like astounding to see, you know? Mhm.
Okay. They will always raise, if you don't want people of color to know anything, put it in the book.
I've heard that statement before.
Yeah. Once upon a time, we weren't even allowed to read it. So, with the writing, me personally, I take writing real seriously because it's something that we weren't allowed to do. And my ancestors would die for this, so,
Absolutely.
sort of.
Do you like to read? Okay, that's good.
Read at night, actually.
Okay, that's good. That's good.
I don't even read.
For me,
You just made me look at it as so really different.
for me, I kind of like audiobooks, you know, with the book. Like I want to read and listen at the same time, you know? Yeah, yeah, yeah. No, but I want to do the same. I want to do them both at the same time.
Oh, you wanna read yourself and hear.
Yes, yes.
Reading faster, and then when I have the voice in my ears.
Really?
Voice in my ears, I can't like, because when I read, I wanna put myself there at that time. I'm like, if I'm reading something from
Oh, wait, you
1940,
you
right now,
read
I'm in 1945.
you read faster than the audio?
Yeah.
That is impressive. I've never heard that. That is really impressive.
Slow. You think they read fast?
When I read.
So when I do it, I listen at 2x speed while I'm reading,
Oh, that's fast.
you know? So like how can I say this now?
That's still slow.
That's impressive. That's impressive what you're saying.
So that I'm trying to slow down.
And that's my issue.
That front floor. It's like, I should be done with this already, but because I read so fast, I gotta go back over to make sure that I'm missing.
Yeah. See, that's my issue right there, because I will read something and then all of a sudden now, like my mind is applying it to something else. And I'm thinking over here while my eyes are still reading. And I'm at the bottom of the page and it's like, what did I just read again? Like, like I don't cure cancer over here. Let me get back to the whole cell thing. I was talking about, Yeah. Oh, that's me. Mhm. Yeah.
Everywhere they don't need to be, we need to be. Like,
I'm gonna simplify it down for you in the future. Don't worry.
Range the mold, so I put my mold as the range. And I put my, and vice versa.
Okay.
Even to question number one.
Yeah.
And divide it backward.
Interesting.
Doing the 11 divided by 5. I did 11 divided by 5. That is why I do.
Mm.
Yeah.
I know I have a theory of what that is, but I'll tell you after class. Yeah.
He said,
Not
which one do you like? Do you have dyslexia?
the fact, but the thing is that dyslexia is a reading thing. It's not a math thing. Yeah, so it's like you see words backwards, or like I'll give you a good example. C and E, right? Lowercase. They're the same in dyslexia, you know? Yeah. So cup and I don't know, eight or whatever. Yeah, yeah.
My thing is
Yeah.
that I tend to like do little stupid shit, like he keeps asking us to solve for y, and instead of instead of doing the two eggs, I'm like, oh yeah, so let me just do the 5y or 5y, like, what's wrong with me? I know I'm not supposed to do that.
I feel like with you just need a little bit of practice and you get it. That's all. The homework is the key to your success. You just do it and then you're good to go. Mhm.
So good, I know it. I even use the scrap paper instead of the calculator. I'm so hyped. And then I come to this classroom and you put a problem on the board and I know if I'm coming in.
Because it's new. Every time I'm in the class, it's new. It's the first time you're seeing it. That's why. Yeah.
Like what we did yesterday,
Yeah.
that was the homework.
Yeah.
I didn't understand why I didn't know what was going on, but I did the
Yeah.
homework and I was doing it pretty good.
Yeah. That's all right. It'll get better. All right, look at this real quick. The general multiplication rule for any event, right? This is the one that I want y'all to take to heart, right? If y'all were gonna highlight something on your formula sheet, this would be the one, right? So the probability of A and B is equal to the probability of A times the probability of B given A. Or the probability of A and B is equal to the probability of B times the probability of A given B. Go ahead. Mhm.
Oh, so, P parentheses A divided by P.
Mhm.
Okay, you see how you got this parentheses and you got this little line between
Yeah.
A and B, which is what is
Yeah.
this line?
That means given. It's a conditional probability.
Okay.
Yeah.
So, and
Yeah. So you're literally just multiplying two numbers together. That's all, you know. But what this one with the line is saying is that that event can't occur until the event before it occurs, you know,
basically, A cannot occur unless B happens. Yes.
or vice versa, right? So, like, for example, here's another one. Let's say that we're talking about playing cards, right? So in a deck of cards, there's 52 cards in there, right? If I take one out, right? Now, and then I go to take out a second card, the second card, oh, huh? No, so the first card, right, had a chance of being pulled 1 out of 52. But the second card that I'm pulling out now only has a chance of 1 out of 51 because I already pulled one out, right? That's what this slash is trying to say. The A The probability A, that's the first one that came out, and they had the chance of the whole shebang, right? The whole deck, right? You
But
know,
then the card out, then it became dependent.
the second event is
The
dependent,
second.
right? On what happened on the first event, yeah.
And the
That's it.
condition, is the standard rotation formula?
This is the conditional probability. The
Oh,
P, the probability of B given A and A given B. That's the conditional.
the-
Yeah. But I promise you, this stuff is like real easy. All you're gonna be doing is multiplying two numbers, and that's it.
But-
Really?
Yeah.
Okay.
I'm-
Y'all better get this right on the test then. Oh yeah, that's coming. That's coming. Yeah. But we got to build up to that though, because we got to know this first before we talk about that. Yeah. Yeah. But this particular formula, right?
That's what-
So, yep, yeah. So we will use either formulas 5 or 6. This is 5 and this is 6, right? According to the information available, formulas 4, 5, and 6 constitute the multiplication rules of probability. They help us compute the probability of events happening together when the sample space is too large for convenient reference or when it is not completely known. Note, for conditional probability, observe that the multiplication rule, probability of A and B is equal to probability of B times probability of A given B, can be solved for the probability of A given B, right? Leading us to, oh snap. Y'all not ready for this. Y'all not ready for this. It's the sauce right here. Leading us to the probability of A given B is equal to the probability of A and B divided by the probability of B. So this is the conditional probability formula.
That's what we just wrote down.
So guess what? It actually is there, right? But you have to solve it for like it was a literal equation, right? This is how it all ties in. So watch. Let me show you. I'm gonna show you an example. So this is what's on your formula sheet. The probability of A and B is equal to the probability of B times the probability of A given B, right? That's what's on your formula sheet. But this formula says the probability of A given B is equal to the probability of A and B over the probability of B. How do you get that? Solve for the probability of A given B. To do that, you just simply divide by the probability of B, right? And what you do to one side of the equation, you do to the other side of the equation. Literal equation. Bam. So as you can see, it's already on your formula sheet. So you see, it's little things like this, right? Why when I say to people like, oh, you don't get like no scrap, like no you can't write your own notes to bring into the test and stuff, right? Because people just end up rewriting things like this. That's already given to you. It's there, you know?
I think it's very sweet, like, it's formula sheet, but they're just too complicated for me.
But I'm explaining them to you, right?
You show me that right now. I've been asking him.
But all you're gonna do is rewrite what I just wrote here.
No, I don't. I get it. It's not.
Yeah.
Yeah. Well, you just have so much fun.
Really?
Yes.
It's just one formula. It's just one formula.
Example, but then I'll let you continue.
Mm-hmm.
So for example, right?
Mm-hmm.
So you had like a whole bunch of stuff up there
Mm-hmm.
for dependent
Mm-hmm.
and independent.
Mm-hmm.
I took everything you said and I wrote, if you have 6 balls for a draw, and then you remove one before the draw, it is now dependent unless you put it back. If you don't remove anything before the draw, it is independent. You see how fucking simple that
true.
is?
That's true.
Simple that is, like, I can read that on the, like, for the test, and I'll be like, yup, I remember. I know
So-
what it is.
So let's see if you really remember.
I'll try.
Here's an example. Multiplication rule for independent events. Suppose we're going to throw two fair dice, excuse me, right? What is the probability of getting a 5 on each die?
If you are throwing two fair, what is a fair dice? I don't think.
So if you go on Fordham Road and you do dice over there, right? like they have like certain weights on it, so certain numbers come up more often than other numbers, you know? But in a fair die, all 6 sides have an equally likely chance of occurring, right? Yeah.
Would the probability be 2 out of 5 since it's two dices?
I like the way you're thinking, right? But not necessarily. So look, here's what I want. I want to know what's the probability of a 5 on die 1 and a 5 on die 2.
Oh, sorry.
Hmm?
So the probability of a 5 on dice 1 and the 5 on dice 2, well, if there's only 1 5 on each dice, then wouldn't the probability be 1 and 1?
Close.
Cause there's only.
All right, so let's work that out, right? Look, what's the probability of a 5 on die 1? Die is a singular form of dice. Yeah. Yeah. And we agree that anytime you see the word and, it's going to be multiplication, right? So this is probability of 5 on die 2. Okay.
When you
So-
put that, you don't really think when you put it like that.
It is.
Yeah.
Like basically what I'm doing is I'm breaking it down. All right. So what's the probability of getting a 5 on a die? Tell me.
One. Because it's.
Out of 1 out of exactly, right? So remember, probability can only be a fraction, right? It's between 0 and 1. Cannot be a whole number, right?
So the whole number is 6 because it's 1 and then 2 and then 3.
It's because right, 6 sides, and I want one side to be 5, right? Yep. So now let's talk about the second die. What's the probability of getting a 5 on the second die? 1 out of 6, right? And then you just multiply these together. What's 1/6 times 1/6?
Is that 2/6?
No.
No, 2/36? No, 1/36.
1/36, there we
I'm
go.
sorry, Professor.
There
You
we-
see what I've been talking
Yeah.
about? Some stupid shit in
No,
math.
no, it's all good. Right? We're just multiplying two fractions. Right? So 1/36. Make sense to everybody? Okay. So that's the kind of questions that we're gonna be getting.
You see, Professor,
Simple, right?
the way simplified it was like magical, right? It was
It was.
so simple, so to the point.
All right, let me make it a little bit more simple. Mm-hmm.
Oh, yeah.
On two different die. Yeah.
Plug it in the way she's doing, so I can write it down too.
How so?
You said 5 would be A, right? And then what would be B? 6,
5.
5?
Yeah. Because I want 5 on the first die, like right here, 5 on the first die. Hold on, let me do this instead. Let's say that one die is green and one die is red. So 5 on the first die, 5 on the second die, right? That's what I mean.
It's not that bad.
Yeah.
So we were right, we say probabilities, right?
Yeah, you write it just like this, right? See, this is my procedure, right? formula, plug in the numbers, answer. That's it, right? If this was a test question, the only other step that I would have wrote is I would have wrote the original formula up top. So I would have wrote the one on the formula sheet. So probability of A and B is equal to probability of A times probability of B given A. That's the only other step that I would have done that I didn't do here. And that's it, right? Got you. You're gonna write it on your formula sheet when it's already on the formula. See, that's what I'm talking about. But that only works for this problem.
And then, Professor, this will be independent?
This is independent.
Independent.
To be honest with you, you don't even need to stress that. Because what happens on one die doesn't affect what's gonna happen on the second die.
So if you put it for one dice before you make a decision, then that's dependent.
Let's look at the sample space. All right. So this is the sample space right here. Really? So look, this is the first die in the first column and the second die in the second column. These are all of the possibilities that could happen when you roll a die. These are the 36 possibilities. All right. And we're looking for only one of them. We're looking for this one, 5 and 5.
Okay.
So that's one out of everything, which is 36. All right.
It kind of makes sense,
It's good.
a little.
Yeah. Then there's other questions that could arise from there, right? Another question I could ask is, what's the probability of getting a sum on the die that's 10? So when I roll the dice, right, they're gonna come up with two numbers and you add them together and you get 10, right? So what's the probability of a sum of 10? That's another thing I could ask you. Right?
No, 2 out of 6.
It won't be. It would actually be 3 out of 36.
But how, if it would be?
So look, how can I get a 10?
So if it's a A and a 2, if it's
Right.
a 5 and a 5.
But here's the issue though, right? You said 8 and 2, right? But the dice, it only goes up to 6, right? So, well, actually, it starts off, it'd have to be 4 and 6, right? And then how I do it in my head is I increase one side and decrease the other. So I add 1 to the 4 and I get 5, and I subtract 1 from the 6 and I get 5. Then I do it again. I add 1 to the 5 and get 6, and then I subtract 1 from the 5 and get 4. These are the three possibilities for the sum of 10. So if I ask you what's the probability of 10 or sum of 10 on a die, let's say it like that.
Hold on, so you did 4 plus 5, 6 take away 1, right?
Uh-huh. So this would be 3 out of 36. Right? And these are the three possibilities. 4 on one, 6 on the other, 5 and 5, or 6 on one, 4 on the other.
So the probability of getting the sum of 10 on the dice is 3 out of 36.
Right. And if you want to see it in the sample space, here's the whole sample space right here, right? This is what I'm talking about. This is the sum of 10. That blue circle.
Question,
Mhm.
did we, so in order to keep it as 3 over 36, you're saying that based off of the fact that getting 5 on dice 1 and 5 on dice 2 was 1 over 36, correct?
1 over 6 each, and then you multiply them together. Yeah.
So that's the only reason why the probability of getting the sum of 10 is 3 out of 36, right?
It's related to that, right? So think of it like when I was doing this is the sum that I want. I want 10, right? But I have to go by what the dice has, right? So I can't use like 10 and 0, that doesn't exist. I can't use 9 and 1, that doesn't exist. Not there's no 9 there. I can't use 8 and 2, that doesn't exist. 7 and 3 doesn't exist. But 6 and 4 exist. And I can go from there. Increase one side, decrease the other, so that you keep the count of 10. And then that's it. Mhm.
Plus one, take away one, plus one, take away, that's pretty cool.
And that's how I do that. Good stuff, good stuff. I believe you have some dice questions on the homework.
That's not gonna be that bad. It'll be okay.
Let's look at another example, a little different. So this is multiplication rule for dependent events. Consider a collection of 6 balls that are identical except in color. There are 3 green balls, 2 blue balls, and 1 red ball, right? Compute the probability of drawing 2 green balls from the collection if the first ball is not replaced before the second ball is drawn, right? So first off, what's my formula? Let me do it in green. What's my formula? It's probability of A and B is equal to times the probability of B given A, right? Okay, now let's go to the question. What did they ask me in the question? They want the probability of what? Right, green and
First ball is not replaced before the second ball is drawn. I'm a little confused.
so what do they want? What colors do they want? Green and uh what's the question asking? 6? No.
Just asking for the probability of drawing 2 green balls from the collection if the
So
first.
so they
ball is
want the
not
probability of green and green, right?
replaced.
So green
This is so confusing.
and green, right?
Got it.
So very simply, right? What I'm doing now is I'm plugging in the story. They want to know what is the probability of green on the first draw. And remember, means multiplication. The probability of green on the second draw, given that you got green on the first draw. Right? But like that, just so we could distinguish. Right? So this is real simple, right? Remember, probability is event divided by total, right? How many green balls are there? 3. Okay. Over what? How'd you get 6? Exactly, right? All right. Over the total of everything. Good, right? Now, I took out 1 green ball, right? How many green balls are there? 2. Over how many balls are there in total? No, how many balls are there in total? 4. No, how many balls are there in total?
6 balls in total.
There's 6 balls in total in the first draw, but in the second draw, how many I have? 5.
It's taken out the.
So I took 1 out, right? And that's it. The rest of it is just multiplication. Oh, yeah. Oh, I got you. I got you.
The answer.
Yeah. I mean, multiply it, 3 times 2, 6 over 6 times 5. These cancel out. So 1 over 5, something like that. Oh. Y'all got calculators. Y'all can do that. That ain't hard. All right.
Okay, let me just write this really quick.
Yeah. but not bad, right?
It's confusing when you put it into word problem, for me.
As long as you just write the formula from the formula sheet, write the story in place of the letters in the formula, plug in the numbers, and then give me the answer. That's it.
And then you got the 3 out of 6 times 2 out of 5 equals. Um, Did you not multiply that? Is that because you're supposed to do reciprocal and divide instead?
Multiply straight across. 3 times 2 is 6, and 6 times 5 is like 30. And then 6 divided by 30 is 1 out of 5.
That's what you like some dividing thing back there.
Nah, just multiply straight across.
Like a word problem though, because I want it to be just as complicated as this.
Mm, might be more simple than that.
But a word problem.
Yeah.
I don't do well with math word problems.
You know?
You know?
Let me show you 2 ways that this question could be answered first before we go to another one real quick, all right? So we got the multiplication rule method. So these events are dependent. The probability of a green ball on the first draw is 3 out of 6, but on the second draw, the probability of green is only 2 out of 5. If a green ball, right, was removed on the first draw by multiplication rule for dependent events, the probability of green ball on the first draw and green ball on the second draw is equal to the probability of green on the first times the probability of green on the second, given that you had the probability of green on the first, right? Which we know works out to be what, 3/6 times 2/5, little math. That becomes 1/5. Yes, they gave out the 0.2. I am not asking for decimals. You can just leave it as a general big fraction. I'm good with that. All right. Let's look at another one. Huh?
Yeah. We should.
You don't have to. It's just simple. You know?
Wait, this is not another problem, you're just showing us the same thing, right?
Yeah, just like 2 ways to answer it. So this is another way that you can do. All right.
So you know, multiply favorite product.
Always when it's fractions, yeah. All right. So each of the 6 possible outcomes, right, for the first draw must be paired with each of the 5 possible outcomes for the second draw. This means that there are a total of 30 possible pairs of balls, right? The next figure will show all the possible pairs of the balls. In 6 of the pairs, both balls are green, right? So the probability of green ball on the first and green on the second, right, is equal to 6/30, which is equal to 0.2, right? So the two methods agree. So here you go. In a few minutes here. So sample space of drawing 2 balls without replacement from a collection of 3 balls, 2 blue balls, and 1 red. Right? So just like how we had all the dice numbers, this is the sample space for the balls. Mhm. Yeah.
And 6 out of 30, which is what we reduced to 1/5.
Right.
Makes sense. And the homework is gonna look just like that.
Just like that, maybe easier. Maybe easier. Oh,
Just try the day, I'll try to start tomorrow.
good. I didn't get a chance to go over addition rules yet, so we'll do that next class, right? But for your homework, look at the multiplication rules. You guys can just do that and then be good to go. I'll see you guys next week. Yes. Have a good weekend, y'all. Let's see. You too. See you soon.